Agenda. In this short video, I'll discuss the following topics. Topic number 1, definition of various concepts. Complement, union of two events or two probability. Intersection, mutually exclusive. Topic number 2, graphic presentation and related formulas. Topic number 3, addition law, conditional probability, and multiplication law. Topic number 1. So let's look at the different definition below. Space, possible outcome, or unique values. So let's use some examples. Suppose we look at fruits, and suppose we have 10 different type fruits, like apple, banana, orange, etc. We have 10. Our space will be 10 different fruits. Suppose we have a number, we randomly pick up 100 number between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 will be our space. Suppose we toss a coin. We either have head and tail. So our space will be head and tail. Suppose we toss a dice. Then we have 6 unique number. 1, 2, 3, 4, 5, 6. The space will be 6 different number between 1 to 6. Complement. Complement will be, assume we have two groups, A and B. Okay, A versus non-A. This indicate if element inside A or outside A. Okay. Union. Union is any elements inside group A or group B. Okay. And another statement is all elements included in A or B or A plus B together is called union. Intersection. Intersection, it means the element in both group A and group B. Mutually exclusive. Mutually exclusive suggests if element in A, it cannot in B. For example, raining or not raining. They are mutually exclusive, either raining or not raining. Happy, not happy, they are mutually exclusive. We are going to use some value or number of fruits to demonstrate all these definitions. Let's look at our space. Below we have 8 different fruits. Then our space unique fruit is 8. Now let's look at our so-called complement. And we know we have a space, we have 8 different fruits. So our space is 8 different fruits. Apple, banana, orange, etc. Suppose basket A has 2 fruits, banana and watermelon. What is complement of 8? So actually, because we know our space is 8 different fruits. Basket A has 2. So A minus 2 will be complement. Our complement will have 6 different fruits. Now we have 2 baskets, basket A and basket B. So basket A has 4 different fruits, and basket B has two different fruits. One is 4, another is 2. Okay, and what is the union of A and B? We put them together, we pick up unique fruits because we know basket A and basket B, they share banana. So the unique number is 5. So the union of A and B will be 5. What is intersection of A and B? And from this simple illustration, we know the intersection will be banana. It is 1. Now, so let's use a graph to look at the complement. The circle is event A, or probability A happened. The rectangular is a complete event. Actually, it's a space. Okay, so we use AC complement. So probability A plus probability of AC equal to 1. This suggests A and A complement summation of these two will be our whole space. Now let's look at the union. So notation of union actually is A and B. Okay, event A and event B. Suppose they have some small overlapping. The shaded area will be union of events A and event B. This is about intersection of A and B. And assume if they have some overlapping. The overlapping area is called intersection. If there's no intersection between A and B, we call them mutually exclusive. Let's look at one example. A small assembly plant with 50 employees is carrying out performance evaluations. Each worker is expected to complete work assignments. First one is on time, and the second, in such a way that assembled product will pass a final inspection. So actually there's two conditions, on time and pass. Results are given below. The second column is number of employee, okay. Late completion of work, 5. So 5 out of 50, they are late. Assembled a defect work, 6. So 6 out of 50, they find products are not good. Complete work late and assembled defect work, 2. So we have 4 numbers. In total, we have 50 employee, 5 employee late, and 6 produce defective product, and 2 employee late and produce defective products. The question is, how many employees perform badly, and what is percentage of these employees? Now, let's calculate bad performers. Okay. We know there are 5 employees late, and there are 6 employees produce defective products. Now, let's look at how many employees that perform not very good. There are 2 conditions. Late, complete work late, then it's a bad performer, or produce defective products, then perform bad. Okay. So we know there are 5 employees late and 6 employees produce defective product. And we know there are 2 have both issues. Okay. The total number of bad performers should be 5 plus 6 minus 2. Why minus 2? Because there are 2 employees double counted. So the total bad performer is 9. So if we use the formula, the union of A and B equals A plus B minus intersection of A and B. We know intersection A and B is 2. 5 plus 6 minus 2 equals 9. For the percentage, we know the total number of employees is 50. So 9 over 50, we have 0.18. It is 18%. On the other hand, we can use relative frequency. So let's look at the last one. Let's look at the last column. The last column is relative frequency. We know 5 out of 50. So 5 divided by 50 is 10%. 10% employee late completion of the work, late. And 6 divided by 50, it is 12%. 2 employee complete work late and produce defective products. So 2 out of 50 is 4%. We use frequency instead of numbers. If we use L represent late, use D represent defective. Okay. So the union of L and D, the probability of L and D equals PL plus PD minus intersection of L and D. Repeat, the union, the probability of union equals the first probability plus second probability minus intersection of these 2 probabilities. So we know for the late, it is 10%. For defective products, it's 12%. And we know jointly they have 4%. So it is 10% plus 12% minus 4% equals 18%. We got the same result.
Shutterstock Music.
If given B, what is the probability A happens? The formula is the joint probability divided by probability B happens. Okay. I try to use this simple method to show you how to calculate, how to apply the formula. We only have 4 numbers. We can simply type. So there are 2 categories, so man and woman, and promoted and not promoted. Okay. The first one is 288 promoted and 672 not promoted. Okay. For the woman is 36 versus 204. Okay, out of total number of men, 288 promoted and 672 are not promoted. Okay. And for the woman, 36 versus 204. Okay, so let's look at the total. The number of the male is simply summation of promoted and not promoted. Sorry, this is promoted and not promoted. Okay, and apply the same formula, summation of promoted women and not promoted. Okay, so this is I called grand total. So this is grand total. Okay, I'm going to put this one down. Just call it grand total. Okay, I repeat the concept here. Okay, so we have 288 men promoted and 672 men not promoted. And so these two numbers for women are 36 versus 24. Okay, the total men 960 and 240. The total person is 1,200. Okay. Okay, so let's treat B. Okay, the B is being a man. A and getting promoted. Okay, so this is we want to calculate what is the probability A and B. So this is equals what is probability getting promoted for being a man. Okay, so this is conditional probability. You are a man, so what is probability get promoted? Okay, it is a ratio. The ratio is A intersection of B. Okay, so actually it is being a man and promoted. Okay, and we know is 288, right? It's 288. And if we calculate ratio, so ratio, the total is 1,200. So this is equals 288 divided by 1,200. So we have 24% men get promoted out of total employee. Okay. Then we look at what is the probability B of being a man. Okay, so we know there are 960 out of 1,200. So this ratio will be 960 divided by 1,200. So this is probability being a man at the same time get promoted. This is probability of a man, the proportion of men. Then the conditional probability is 24% divided by 80%. So this is, I'm going to make this formula available. So this is conditional probability for being a man get promoted. Similarly, we can look at being a woman and get promoted. Okay, exact same things. Okay, then the numerator is how many women promoted divided by total. So this is about 3%. Okay, the next one is what is proportion of women? It's also smaller. The ratio of these two will be our conditional probability. So the conditional probability for being a man get promoted is 30%. The conditional probability for being a woman get promoted is only half, is 15%. The multiplication law, is a joint probability A and B equals probability B times conditional probability for B given A happens. From previous discussion, we know the conditional probability. We have conditional probability A given B. It's a ratio of joint probability divided by probability B happens. Actually, these two are the exact same things. We can use conditional probability to find multiplication law. Definition of independence. If the probability of event A is not changed by the existence of event B, we would say that events A and B are independent. This suggests A and B has nothing to do with each other. Two events A and B are independent if the conditional probability A happens given B equals probability A. This indicates the probability A has nothing to do whether B happened or not. Alternatively, we can claim the conditional probability of B happens given A equals probability B. It has nothing to do with A. For example, we roll a dice, then flip a coin. And whether we get a 1, 2, or 3, when we roll a dice, has nothing to do with flip a coin. These two events are independent.
Shutterstock Music.